Okay, and here we are at the bottom of page 1 for 3.2. And just to catch us back up again, I missed typing this on the original set of notes, so I'll fix that. But it should say solve each proportion as the instructions in orange for these next set of problems. So let's look at that. And the tip for solving one fraction equal to one fraction, we've actually practiced this in 2.4, is to cross multiply. And cross multiplication is really just a quickened version of finding the LCD and multiplying both sides by the LCD. Okay, you don't have to memorize this whole idea of cross multiplication, because you could eliminate the fractions using the LCD too. Okay, so or you can eliminate fractions by multiplying every term by the LCD. It all still works. Cross multiplication is just a quicker version of this idea of trying to eliminate the fractions. You don't have to figure out the LCD. You just go ahead and do the cross multiplication. And if you would like to see why that is true, I'd be happy to do that one-on-one or club hours, even if there's time in class. That's definitely a valid question. Why does that work? It's not just coincidence. So I'd be happy to go through that. But for now, let's try a couple of these together. So looking at number 18, we've got one fraction equal to a fraction. Granted, the fraction looks a little different than we're used to because we've got a variable and something happening to it in the numerator of the one on the left side of the equal sign. We've got x minus 4 instead of just a plain old number. Okay, it doesn't change how we do this though. Okay, we cross multiply. We take 5 times the numerator on the left side, so it's 5 times the x minus 4. That equals, and then we do cross multiply up and land here, 10 times 3. That equals 30. That's where we got the 10 times 3. Okay. And then from there you have an equation that you should recognize how to solve. We've got parentheses here that we need to remove. We'll use distribution because the minus tells us we can't just do one multiplication. We need to apply it to all the pieces. So 5x minus 20 equals 30. What's happening to x? Well, it's being multiplied by 5 and then 20 is being subtracted. So we reverse the order, use opposite operations, peel away the things that are happening to x from the last thing back to the first. So the last thing is the minus 20. We'll do the opposite, add 20. 5x is equal to 50. Then we need to remove the 5. We do the opposite of operations. It's multiplication, so we divide by both sides by 5 and we get x is equal to 10. And we can check that. Okay, put that in there. 10 minus 4 over 10. Does that equal 3/5? You get 10 minus 4 is 6. 6/10 does indeed reduce to 3/5, so it checks. So our answer is 10. And of course we'll want to practice our set notation again. Got away from that a little bit with all the story problems we've had because those had a label that could finish telling the story. So here we just want to identify that this is a solution to an equation. 10 is what makes that equation true. Okay, let's look at number 22 again. It is great to ask yourself what's different. If you are hesitant at all how to start a problem, especially if you've been going along at a pretty steady clip and things have been coming together, then all of a sudden you look at one and it looks Greek to you. It looks like you don't know what to do. You hesitate. Then pause and ask yourself what's different. What's different between these two? What was different here was there was a x, there was something going on. We were used to seeing one fraction equal to one fraction, all numbers. Or just maybe a plain variable. Here the variable was being operated on. Didn't change how we do it, we just ended up with some distribution. Same thing here. What's so different? We've just got variables on both sides. That shouldn't throw us. We know how to solve equations with variables on both sides. We just need to get it rearranged into a form that makes sense to us. So you could choose to eliminate fractions here by multiplying both sides, every term really, by the least common denominator, which would be 24. Or we can, cross multiply. Okay, so 6 times the x plus 7 equals negative 4 times the x minus 12. So I've got a denominator times the numerator, and it ends up on the side of the numerator. And then the denominator of negative 4 times the numerator, and ends up on the side of the equal sign that the original numerator was on. So that's how you determine where those things land. It's kind of travel up and land, and then travel up and land. And now we've got an equation. We've got variables on both sides. We've got parentheses. Those need to be dealt with first. So let's distribute, and we get 6x plus 42 equals, distribute that negative 4 as well, negative 4x plus 48. Negative 4 times negative 12 is plus 48. X's are on both sides. Let's go ahead and add 4x to both sides. Adding because the sign in front of the term I'm trying to move was negative, so I do the opposite of that. So add 4x. That gives me 10x plus 42 is equal to 48. Subtract 42 from both sides. I get 10x is equal to 6. Divide both sides by 10. And I get x is equal to 6/10, which reduces to 3/5. And with a calculator, this might work pretty handy. 3/5 is the same as 0.6. So you would do 0.6 plus 7 is 7.6. Pardon me. Divided by negative 4, does that equal 0.6 minus 12 divided by 6? And you would find that that works in the equation. Okay? And so we do it in set notation now. 3/5 is our answer. Okay, and finally some try problems. Two different choices, one with pretty basic, kind of back to the look of 2.4, and then more of the today look, what we're doing in 3.2. X's on both sides, one has something happening to it while it's in the numerator. So hit the pause button, come back for some answers. Okay, so on 16 you should end up with, in your little set notation, negative 36 as your answer. And then on 20, you should end up with 5 as your answer. All right, we will see you on page 2. Great work.